I'm again dealing with a random variable z that is normally distributed with mean 0 and standard deviation 1. So again, this is a standard normal distribution. In this case, though, I want to find the probability that z is between two values. That z is between 0.1 and 0.8. Okay? So again, good idea. Start off by sketching out what we're looking for here. So rough bell curve. We're dealing with a standard normal distribution, so the mean 0. And I'm interested in the probability that a randomly chosen z value will be between 0.1 and 0.8. Okay? So that looks like 0.1 is a little bigger than 0, and 0.8 is bigger than that. So somewhere around here. You don't have to be perfect. So I kind of want the area of this region. That would be the probability that z is between 0.1 and 0.8. Okay? Now, how do I find this probability? This is a little tricky, right? That p-norm function, so if I said like p-norm of, say, q equals 0.8, that wouldn't give us this probability. That would give us the probability of being just less than 0.8. That's way too much, right? If I did 0.1, that gives me the probability that we're less than 0.1. So we need to kind of use this p-norm function in a way so that we can reconstruct this with only this kind of expression, with only this kind of probability that calculates the probability to the left of some value. So what we are going to do is we're going to do a little arithmetic here. We're going to start by taking more than we need. Okay? So I'm going to start with that bigger value, that 0.8. And I'm going to calculate all of the area to the left of that. So that would be probability that z is less than 0.8. Now, I like this one because I can use that p-norm function to calculate that probability, can't I? That's the kind of probability that that p-norm function allows me to calculate when I'm interested in values less than some number. Okay? Okay, but the problem is that's, of course, too much, right? It does get me everything I want if 0.1 is about here. This is what I like, and it does give me all of that, but it also gives me a bunch of stuff that I don't want, right? So what I'm going to do is I'm going to take off that extra. I'm going to subtract away everything that I don't want. In this case, anything to the left of 0.1, that's what I don't want. So that's what I'm going to take away. There we go. Looks a little better. Okay. And so that would be probability that z is less than 0.1. Okay? And so I can rewrite this expression here, this probability that's in between two values, by taking the probability to the left of the larger value minus the probability to the left of the smaller value. I first take too much, and then I subtract out the part that I don't want. Okay? I take all of this over here, but then I subtract out this over here because I don't want that. That'll leave me with just this part here. Okay? So probability of the larger minus probability of the smaller. So what would that look like here? P norm q equals 0.8. That's probability to the left of the larger of the two values. Minus, and now take out what I don't want, which is anything to the left of the smaller. P norm q equals 0.1. I only want to stay in between those. Okay, so I want everything to the left of here, but not what's to the left of here. So that's why I subtract this away. And that's going to give me the probability in between those two values. And so I can calculate any kind of probability I want using this p-norm function, which only gives me the probability to the left of the value we input.